Hey, welcome back. Previously, we talked about how to calculate the empirical formula given percentages of a compound. Now we'll take a look at how to convert the empirical formula to the molecular formula. The main formula that we will use will be X times empirical equals molecular. That is, X times empirical formula equals molecular formula, where X is our factor of difference. That is, the number X will be multiplied times the empirical to result in the molecular. Let's take a look at some examples of this factor in use. First, I will list some empirical formulas: CH4, CH, and CH3. You can notice they cannot be reduced any further down, making them empirical. And now I will write some molecular formulas that go with the empirical. C2H8, C4H4, C6H18. Now, the factor X that's involved: 2, 4, and 6. If you remember from previously, X times empirical equals molecular. So 2 times CH4 equals 2 to the C, 2 to the H, C2H8. 4 times C to the H, 4 to the C, 4 to the H, C4H4. Lastly, 6 times CH3, 6 to the C, 6 to the 3, C6H18. Let's take a look at how we can apply this. Here's a problem. A molecule with a formula mass of 26 grams has an empirical formula of CH. What is the molecular formula? We will start with our formula: X times empirical equals molecular. Since we were given a mass for the molecular formula, we will have to use the empirical formula to calculate its mass and then use the ratio of the masses to solve for the X factor. We were given that the molecular formula had a mass of 26 grams, and we can calculate C and H using the periodic table to be 12 and 1 respectively. We know that there's one carbon for 12 and there's one hydrogen for 1. So our empirical formula is 13 grams. We put the numbers into the equation, and then we're going to do some algebra. We find that the X value, the difference here, or the changing factor, is 2. 2 will be our X. Now we can take the same equation again. X empirical equals molecular. We're going to use the factor 2 that we solved for and put the empirical formula in. And then we will distribute to the C and the H, and we'll get C2H2 as the final answer. That's it. See you next time. Bye-bye.